Hello, grade 5. How are you? Hope you are all fine. This is lesson 4 of this term, and this is the easiest lesson in the whole year. It doesn't mean that all the other lessons are hard, but this lesson is really, really easy. You know almost everything about it. What is the objective of this lesson? We're going to actually talk about the three states of matter. You already know them: solid, liquid, and gases. And we're going to talk about specific properties for each state of matter. Then we're going to talk about how does matter change from one state to another, which you already also know about it, like melting, freezing, and stuff like this. Okay, so let's start with solids. Any solid, for example your iPad, does it have a definite shape? Of course. Definite means like it's proper and it's known, it's a fixed shape. Does it have a fixed shape? Of course. Okay, does it have a definite space, which is volume, definite volume? Of course. Does it take a specific space from your desk, for example, where you are putting it now while listening to me? Yes, of course, it is taking a specific amount of space. Okay, so till now it has a definite shape, it means a proper fixed shape. Any solid has a specific shape. Either it's a glass of water, it's an iPad, it's a book, it has a definite shape. And also it has a definite space. It's taking a specific space from your desk, from your bed, from your bag, whatever, wherever it is. Okay, what about the arrangement of particles in solids? Of course, solids, because they are like really strong, the particles are really close to each other. Here, can you see? I circled it in blue. They are really tightly packed. Tightly packed, it means as if someone is tying them. Okay? From how strong they are packed and very strong to each other, very close to each other. So, we are going to, in every state of matter, we're going to talk about three things: shape, volume, and how the particles are arranged. So, for solids, they have a definite shape, definite volume, and particles are so close to each other, or you can say they are tightly packed. What about gases? Liquids first. Now, when I have a glass of water, for example, does the water take a specific amount of space? Let me write here: volume is equal to space. Does the water take a specific amount of space in the cup? Of course. For example, when your mom tells you, get me like 1 liter of milk while you're coming back, so it means what? 1 liter is a specific amount of volume. Like for example, a small can of Pepsi, for example, it's 250 milliliters. This is the amount of space the Pepsi is taking from the can. Okay, so all liquids do have a specific amount of volume. It means the amount of space they are taking from the container, either a cup or a bottle or anything the water is in. Even the pool, guys, the swimming pool. The water inside the swimming pool is taking a specific amount of space. It depends how much water they added. Okay, what about shape? This is easy. If I pour water on the floor, if the water was in a cup, in a square cup, for example, if I pour it on the floor, will it still be square? No, it's going to spill and take like pour all over the floor. It means what? It does not have a definite shape. It takes the shape of the container. If the bottle is circular, it will take the circular shape. If sometimes you can add water to a balloon. If the balloon has a letter M, it will take the letter M. It depends. Water or liquids do not have a shape. It takes the shape of what? The container. Okay, what about the last point, the arrangement of particles? Are they tightly packed as solids? No, they are less tightly packed. Okay, what can we say? They flow past each other. Like something which is, let's say, any liquid, guys, it is flowing, like sliding, okay? It's not really tightly packed. Then, gases. Gases I will make it easy for you. They don't have a definite volume, they don't have a definite shape. So two axes. And of course, particles move freely all over the container or the room, or they move freely and fastly also. Okay, miss, how they don't have a shape? Okay, now me and you are talking or listening to each other during a live session, and between us and between your screen and your face is air. So is air taking any space? Do you tell the air, please move, I want to see Miss Nada in the screen? No. So this is a proof. No, gases don't take any space. Okay, do they have a specific shape? No. No, you don't. We don't see gases in triangular shapes or circular. No, they don't have a shape. But if, for example, if I blow a balloon, they take the shape of the balloon. So just like gases, like liquids, they take the shape of the container. And we can add this point here. They can take the shape of the container. Can take the shape of the container. Whether it's a balloon, it's whatever it is. And the movement is always freely in gases. Okay, guys? Okay. Now we want to talk about how matter moves from one state to another. Let's say from solid to liquid. Concentrate in the picture. The ice changed into water. How? By heating. So when you heat something, you actually add energy. Okay? So when we add energy to ice, it will start melting. And when we add energy to ice, the particles start to move faster and faster and faster. That's why it melts. Okay, what about liquid to gas? The same thing. When I start to add more heat to liquid, okay, more energy, it will the particles will start to move quicker and quicker and then turn into gas. And the process of a solid turning into liquid is melting. The process of a liquid turning into gas is evaporating. So when you add heat, you're actually adding more energy. What about removing heat? So when I remove heat, I am removing energy. For example, liquid to gas. Liquid to solid. From liquid to solid. So this is what from liquid to solid, it's freezing. And when energy is removed from a gas, if we want to get water again from gas, we can remove energy and then it can start to condense. So gas will form into a liquid. So here this is freezing. In the first picture it is freezing. And here condensation in the second picture. Condense. So here what I am doing, I am removing energy. When I remove energy, how will it freeze or condense? Particles move more slowly and slowly. Let me highlight it in yellow. Slowly and more slowly. Okay, so it is exactly the opposite of the adding energy. When I add energy, particles move quicker. But when I remove energy, particles move slower. And you have to know this. And we're going to actually have a virtual lab on it, so it sticks to your minds. And here is a summary of how we add and remove energy. So from a solid to liquid, look at the red arrow down, it is melting. And from liquid to gas, it is evaporating. And if you noticed the red, it means adding energy, adding heat. And what does it mean? The temperature. Of course, when I add heat or energy, it means the temperature is going to increase. So the red means more energy. What about the opposite? If I want gas back to liquid, I'm going to remove energy, cooling. So from gas to liquid is condensation. From liquid back to solid, I'm going to also remove energy by freezing. So when I remove energy, the temperature goes down, and down there is an icon for the temperature. So look at the color of the arrows, guys. This lesson is really simple. I hope you all get a 10 out of 10 in the quizzes of this lesson. Thank you, guys.